Okay guys, so this is going to be mole worksheet number 2. So it says calculate the number of atoms found in 25 moles of phosphorus. Okay, so anytime I see atoms, I have to go through Avogadro's number. So we say 25 moles of P over 1. And I say 1 mole of P gives me 6.02 times 10 to the 23rd atoms of P. So we're going to put that in our calculator. We'll do 25 times 6.02 times 10 to the 23rd. And we get 1.51 times 10 to the 25th. And that's going to be atoms of P. It says calculate the number of moles found in 513 grams of ammonium dichromate. So we're going to have to find the structure for ammonium dichromate. Ammonium is NH4 with a +1 charge. Dichromate is Cr2O7 with a -2 charge. Okay, so we crisscross, and that's our structure right there. So we have 2 N's. N weighs 14. Hydrogen, we have 8 hydrogens. Gotta make sure we multiply. Chromium, we have 2 chromiums, and chromium weighs 52. And then oxygens, we got 7 times 16. 112. Okay, so we're going to add all that together. 112 plus 104 plus 28 plus 8. And you get 252. Okay, so we're going to take 513 grams of ammonium dichromate. And we want to go to moles. So anytime I see grams, I have to go through the formula weight. So our formula weight is 252. Okay, so we're going to divide. 513 divided by 252, and you get 2.04. of ammonium dichromate. Okay, number 3. It says calculate the number of atoms of chlorine found in 411 grams of chlorine gas. Okay, so remember last class we talked about diatomic molecules. Okay, nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and hydrogen. Okay, so they exist in nature as pairs. So chlorine gas is actually Cl2. Okay, so we're going to start with our given over 1. So 411 grams of Cl2 over 1. Now, when we go to do our formula, this is tricky because chlorine is right here. It's 35.45. So it's really close to 35.5. But we're going to round down to 35. So 35 times 2 gives you 70 to 1 mole of Cl2. Now, anytime I see atoms or molecules, I need to make sure I go through Avogadro's number. So 1 mole of Cl2 gives you 6.02 times 10 to the 23rd molecules of Cl2. And then we got to go to atoms. So 1 molecule of Cl2 gives me 2 atoms of Cl. Sorry, I hit my camera. Okay, so we're going to put that all in the calculator. 411. So we do 411 times 6.02 times 10 to the 23rd times 2. And we're going to divide by 70. Okay, so we get 7.07 times 10 to the 24th. Okay, and that's how we do that. Number 4, calculate the number of grams found in 36 moles of hydrobromic acid. So we should know this from last test that hydrobromic acid is HBr. Okay, hydro meaning there's two elements in it. Okay, so we get 36 moles of HBr and we write over 1. We know that 1 mole of HBr is equal to its formula weight. Okay, so anytime I see grams, I have to go through the formula weight. So bromine, let's go out to the side and do it. So HBr. So I have 1 hydrogen. That weighs 1. Bromine, we got 1 of those and it weighs what, 80? Yeah, 80. So my total molecular weight is 81. So put it here, your units cancel diagonally. I'm left with grams. So 36 times 81 is 2916 grams of HBr. Okay, number 5, it says calculate the number of atoms of sodium found in 100 grams of sodium carbonate. Okay, so sodium is Na with the +1 charge. Carbonate, CO3 with a -2 charge. And we crisscross. We're going to go ahead and have to find the molecular weight. So sodium, you got 2 of those at 23. That's 46. You got 1 carbon. At 12. And you got 3 oxygens at 16. I get 106 grams. Okay, so I'm going to take 100 grams of Na2CO3, put it over 1. Now, anytime I see grams, I have to go through the formula weight. That's equal to 1 mole. Okay, and I'm trying to go to atoms or molecules. So anytime I see atoms or molecules, I have to make sure that I go through Avogadro's number. So 1 mole of Na2CO3 is equal to 6.02 times 10 to the 23rd molecules. Okay, I'm gonna run around the room, so. Okay, and then we know that 1 molecule of Na2CO3 has 2 atoms of Na. Like that. Okay, so we're going to put that all on our calculator. So we're going to do 100 times 6.02 times 10 to the 23rd times 2. And we're going to divide it by 106, and you should get 1.14 times 10 to the 24th atoms of Na. Okay. Number 6, it says calculate the number of moles in 32 grams of magnesium. So anytime I see grams, I have to go through the formula weight. Magnesium has a formula weight of 24. So 32 divided by 24, you get 1.33. Nothing more to that one. And last one, it says calculate the number of grams found in 8 moles of lithium. So we start with 8 moles of Li over 1. Anytime I see grams, I have to go through the formula weight. Moles cancel with moles. So lithium weighs 7. Okay, and 8 times 7 is 56 grams of Li. Okay, so that's been mole worksheet number 2. Attached in the folder that is on Blackboard, I have a folder called Extra Practice Problems, where I have the answer keys. I didn't do videos for that just because it's a little overkill, but if you need help with it, make sure you reach out and let me know if you need help or anything. Have a good one. Thanks.